bottom of f of x and it's a graph. I mean, I can present
Yes.
it to you.
Yes. Yeah. Show us so we can see.
It's just unusual because normally the smaller value is at the bottom. So I'm looking at f here where 10.
Yes, but remember 10 to 0 from f of x dx is the same with the opposite from 0 to 10 from f of x dx. This is one of the properties of the definite integral that we discussed last time. You don't have to determine in the way they want you to. You can change it into the opposite from 0 to 10.
Gotcha. Okay.
Yes.
So if it is like that, we then just change the sign. So
it depends on the graph, but yes, you can always change this into the opposite by swapping.
Gotcha. Okay. Thank you.
Thank you. Good. Anything else? Other questions? Do you need any other help? You can always stop me. So now what would you like me to continue? Can we continue with the second type of integral and then the substitution rule for those, for both, or you want something else?
Unless Aaron has other questions.
Nope, I don't think I have any.
So you want us to work on those too? Okay, so I want to start with something that is very important. Can anyone give us a function? Any function you want.
Like x squared?
Yeah.
Plus natural log x. So we've done this before, so let's do it one more time because this is very important. Can anyone give us a derivative and anyone to give us the differential?
The derivative is 2x plus 1 over x.
Good. And the differential? What's the notation for the differential?
The d, are you talking about dy over dx?
Good.
Or dy equal?
Good. So what is so the differential, the notation is dy, but what do I have to write?
Is this something like something times dx?
Yes, not something, this.
Oh yeah, it's just that plus dx.
Excellent. That's it. So please understand the difference between the two. The differential of y, it's f prime of x times dx.
So I'm sorry, are we starting a new?
Yes, but I wanted to review this. Yes, we haven't started anything yet, but I wanted to review this now because this is very important for what we're going to look at. Good, so keep this in mind for now. So we already know what a definite integral is. So we said the integral from a to b, so this is definite integral from f of x dx is the antiderivative from a to b, which is f of b minus f of a, for this function being continuous on ab. So this is what the definite integral represents, and this is a number. Okay, there is another type of integral called indefinite. The indefinite integral from f of x dx is the uppercase f of x, the antiderivative, plus a constant c. So this is the most general antiderivative. So what's all this? Why? We already know how to calculate the most general antiderivative. Yes, this is a different notation. By indefinite means general, right? It's not definite. It doesn't start here and ends here like the definite integral. It's indefinite. It gives us a family of functions. Another way of writing the most general antiderivative. Sorry about that. Okay, so here we can always check. We discussed that. How do I check? How do I check this answer? I differentiate the left-hand side and I differentiate the right-hand side. In other words, uppercase f of x plus c prime has to give us this function. So this was the first thing we did in section 4.9, but I did not use this symbol. Now we can. So we only determined the most general antiderivative, or if we were given an initial condition, we determined one function. Now we are ready to just use the symbol. It's still the same thing. It's still s. It's still stretched s. It's the same symbol with this one, but it's the indefinite integral that results in the most general antiderivative or a family of functions. And this one is very easy to check. I differentiate my answer, make sure that I get f of x. If when I differentiate my answer, I don't get f of x, this is wrong. Okay. Now, I want to jump directly to something called the substitution rule for both. And this is the last section of this course, but we still have some leftovers. So we reached the last section. We're going to finish it, but then go back to those tiny little pieces that I skipped through because I wanted to get to the core. But we will not skip the rest. Okay, we have a few things to go back to. Okay, so my question is, why do I ever think of substitution? I use a substitution if it makes my life easier. If it makes an integral, definite or indefinite, doesn't matter, easier to calculate. If the substitution doesn't make it easier to calculate, then I don't need the substitution. There are many techniques of integration. What is the technique of integration that we use so far? Straightforward. For example, the integral from 2 to 4 from x squared dx. We just found the antiderivative, x to the third over 3 from 2 to 4, and we plugged it in. This is the second technique of integration, using substitution to make it easier. There are many other techniques that you will study in Calc 2, but these are the two that we study here. Direct. From x squared, I was able to find the antiderivative and then calculate. The second method is substitution. So, I am going to, let me just put here 6. I'm going to share my screen. And
Could you go back to that paper for just
oh,
a second?
absolutely. Yes.
Okay, thank you.
Thank you. So I'm going back to, I hope, yeah, of course. I was just hoping. I'm logged out, of course. Most of the time I'm logged out. I'm kidding. Okay, I'm back in. Maybe. Yes, I'm back in. Go to the book, chapter 5, and directly to section 5.5. So let's choose anything from 9 through 54. Slowly, we're going to work on examples till Aaron says, I got it, enough. That's what he said to me several times, and I love it. When he says, okay, I got it, move on, then I know I have to move on. So we are talking about indefinite integrals. In other words, a most general antiderivative. In other words, the family of functions. Yes, I'm ready. Who would like to pick? If not, I will.
Number 10.
Number 10. We want to start with number 10. And this is the integral, the indefinite integral from 5 minus 3x to the 10th power dx. Perfect pick. So the thing is here, can I determine this integral without substitution? Yes, of course. But it will take me a while to raise 5 minus 3x to the 10th power. I will get 11 terms. And by the time I finish, I will be exhausted. So there must be another way. Yes. If I denote, I will say let be what? Any letter. Give me any letter, not X. Any letter. A, B, C, W, Y, Z, U, T. Any A. Fine. We want to use A. Is that what you said? You had said A?
I said K, but
You said K.
Oh, I heard A too.
That's fine. We want K. So let K be what?
Are we setting it equal to the function?
Equal to what?
So 5 minus 3x.
Exactly. 5 minus 3x. See this? When I change the integral from blah, blah, blah dx, I have to have the integral now in dk. So can anyone give us dk for this function?
Oh, is it just k to the power of 10?
That's why we started with this. Okay?
Oh.
That's why I refreshed your memory on this. So I get the correct answer, please.
negative 3 to the power of 10.
We're talking about k, which is 5 minus 3x. And we want to find dk.
So is that
I have a function that is k.
negative 3 x dk over dx?
Okay, let's do this again. No worries. I have a function, x squared plus natural log x. To find dy, because this is y, that's why we have dy.
Differentiate first.
So we differentiate it. Since the variable is x, all I had to do is write dx. So then
It's just negative 3 dx.
exactly. Absolutely. Absolutely. Negative 3 dx. Stay with me.
What about the exponent?
We
Sorry,
haven't
that's
finished.
the
We
y.
haven't finished. We
Okay.
haven't finished. You're way ahead of me. That's awesome.
Okay.
So now, I have negative 3 dx, but I only have dx here. Here's what I'm going to do. Just because this is just a little adjustment, it's a little factor, I will multiply here by negative 3, but I have to divide by negative 3. So negative 1/3 times negative 3 is 1. I didn't change the problem. But now I have a negative 1/3 in front. I will write it one more time. Then, can anyone tell us what this is? Because negative 3 dx will be dk. I have
That's
an
just k to the power of 10.
That's it. That's it. I'm going to write this one more time because it's not clear here. So I'm going to write it here as negative 1/3, the integral from k to 10 dk. Negative 1/3. Which function prime is k to the 10th power?
5 minus 3x.
K to the 11th over 11 plus
Oh.
a constant c. So this is negative 1 over 33, k to the 11th plus c, but then I have to go back to the variable that was given to us. The integral was given in x. The answer has to be in x. So I go back and replace k by 5 minus 3x. 5 minus 3x to the 11th plus a constant c. Done.
So can we? All right, so the first thing we had to do was replace the function with k.
Any letter you want except
any-
x.
Yes.
Any letter. We decided k, we'll now use y next time, we'll use u next
Okay.
time, and t the following,
Step
whatever.
one was to set the function equal to a variable.
Correct.
Then step two.
I have to
was-
find dk because the integral has dx. When I move from x, I have to move completely to k, and there is no integral without d something. If the
Right.
variable is k, then it has to have dk. If the variable is x, then it has to have dx. If the variable is u, it has to have du.
Right.
Because it
Okay.
was just a tiny number that needed to be adjusted, you can say, I want to solve for dx. The same thing. If you solve for dx, you have dk over negative 3. And that's how you get the negative 3 in front, 1 over negative 3. Same thing. But because it's so easy and it's just one factor, I recommend multiply and divide. You can say no, fine, I want to solve for dx. Solve for dx. And you still have dk over negative 3, and 1 over negative 3 will go in front. Same thing. It's up to you.